So covariance and covariance correlation correlation relationships, and let's discuss that first, eh? So let me quickly announce this. So here's the relationship, right? So correlation between x and y is equal to covariance of xy divided by the standard deviation of x times the standard deviation of y. Right? Relation चाहिँ यो हुन्छ हिजो चाहिँ के प्रब्लम भएछ भन्दाखेरि सो मैले कोभेरियन्स 2 गराएँ नि त्यो 2 गराउँदाखेरि चाहिँ त्यो चाहिँ प्रब्लम हुन्छ है म यहाँ 2 गरेँ यहाँ वार्निङ पनि दिइरहेको रहेछ है सो वी डिडन्ट quite take notice of that. Okay? So it's connecting. Okay, so it's connected. Just let's say so if I run this. Oh yeah, it is. So running yes, covariance is not positive semi-definite, right? So you're saying so of course you're saying midline, your relationship maintained or something. Okay, so this is your relationship. Clearly this is above, and is result above 1, right? Or minus above 1, right? So which is not correct, right? So so if I put 1.5 here, then that should do it. Similarly 1.5, right? So now my covariance minus 1.51, right? So my mean 0 0 and unerको covariance between x and y, yeah, but you do a column speech go minus 1.5. So if I do this, obviously I don't get any warning. Okay? So it went fine. Okay? Over yoga we can calculate this one. Okay? So I'm calculate. Let's go back here. Now it's a covariance it's the covariance is according to this covariance matrix answer. What is the covariance between those two variables? What is yours? The covariance one of the yours, this is 1.5 minus 1.5, right? The thing is only they have the thing like, so our covariance matrix is so our covariance matrix covariance matrix, right? Co-matrix is equal to just as so go back and see 1 minus 1.5 1 minus 1.5 and yeah minus 1.5 because this is a mirror image, okay? This is what was let's see 3, okay? 3. So you now of course, so if you look at this, say you x1 x2 you would say really के गर्छ भन्दाखेरि यसले दुईवटा हैन x भन्ने एउटा त्यो दिन्छ हैन 100/2 matrix जुन हाम्रो कोड अनुसार त्यसलाई हामीले x1 र x2 बनाउँ हैन. So x1 there are a bunch of values here, x2 को bunch of values हुन्छ हैन. अनि के छ भन्दाखेरि यसको mean हामीले mean यहाँ कति दिएको छ हेर्नुस् त. Our mean is 0 0 भनेपछि यो दुवैको हैन दुवैको mean यसको mean पनि mu equal to 0 हुन्छ and यसको पनि mu is equal to 0, है दुवैको mean 0 हुन्छ. अनि त्यसपछि standard deviation यो कति हुन्छ यो अनुसार my covariance matrix हेरेर covariance matrix अनुसार what is the standard deviation of x1 कति हुन्छ ल भन्नुस् त mu x र mu y, है. Okay, so अब standard deviation भनेको sigma, है. Sigma x कति हुन्छ भन्नुस् त sigma x is equal to I think we discussed it yesterday, right? When you go here, see, this is x1, x2, right? x1, the x2. When you see using here, using x1 or x2, sorry, x1 or x1 could be score, right? So x1 or x1 could be score. When you see that is the that is the one
sigma x.
Rather sigma one happening. It's variance. The sigma like a standard deviation. So then your keyword, one keyword. So your one keyword. What is one? Using keyword. Sorry? I was listening.
Variance.
Variance, very good. Thank you. Thank you. Right? Variance, variance variance. Variance of x1. Right? X1, x1 to variance. Right? And this was using your three thing here.
Variance of x2.
Right. Yes, thanks. Thank you. Okay. So variance of x2. Okay, variance of x2. Right. Okay, so you guys are clear on this, right? Above any this one right here. What is this? This one? Mirror image. What are they? UQ 1.5 in this case. Q. That's the covariance. Okay. It's a covariance between the two variables, x1 and x2. Right? Yes, I'm clear. Say the right. Okay, when you see, let's plug in the numbers. Say cov xy kati bhayta. What is the cov xy? Yahanera मैले के राख्ने? Given the covariance matrix.
Minus 1.5.
Okay, very good. Minus 1.5. है त्यो covariance भन्नुभयो. अब यो अनि standard variance भनेको के हो? Standard deviation sigma x भनेको के हो? भनेपछि variance को square root हो के हैन? हो variance को square root है sigma.
Oh sir.
है भनेपछि this is square root of 1 times square root of 3. है मिल्छ? Sigma y भनेको sigma x भनेको square root of 1 है sigma y के हुन्छ? Sigma y is equal to sigma भनेको standard deviation. Sigma y कति भयो?
Root under 3.
हैन? Very good. Variance of x2 rather x1 x2. x1 x2. Now let's clear. x2 हैन जस्तै गरी sigma x2 हैन sigma x2 मैले यहाँ पनि यो चेन्ज गर्नु पर्यो है so that we have consistent notation x1 and x2 and x1 and x2 right? Okay, so now it makes sense, right? So अब यो हामीले क्याल्कुलेट गर्यो भने कति आउँछ हेर्नुस् है minus 1.5 divided by you basically भनेको 1 minus 1.5 हैन divided by square root of 3 हो नि त isn't that right? Right? So you got it, you can see here. So minus 1.5 square root of 1 times square root of 3. You got here minus 0.86. Okay? Okay? When you round it up, minus 0.87. Okay? So you're thinking about what is this? Minus 0.87 Q. What is this one? This thing? Correlation coefficient. Right? You think you Pearson correlation coefficient भन्छ हैन correlation coefficient. You बुझ्नुभयो? Okay, so that's what it is. Okay, अब यसैलाई हामीले यहाँ हामीले हामीले यहाँनेर यसरी निकाल्यो भने you get very close to the random number भएको हुनाले है. So let me just run time run out. So the random number exact on the it's very close. Understand? Minus 0.87 I. Right? Column 0, which is x1, right? X1 and column 1 x2. Right? So column 0, column correlation coefficient minus 0.87 I, right? Which is what we got here. Right? Okay. So so that's how it works out. Right? Okay, another thing I want to show you. Right? What I want to show you is this one. Just say if I do say यसमा say so यसमा अब mean 0 0 छ है covariance चाहिँ 1 minus 1 minus 1 1 हो भनेपछि यसको can you calculate the correlation of this? यसको correlation कति हुन्छ? Correlation coefficient rather.
Correlation coefficient भनेको 1
-1 हुन्छ sir.
-1
-1. Very good. Because -1 divided by square root of 1 times square root of 1, which is -1. Right? Very good. -1 मा के भयो? यसको -1 भयो भने के हुन्छ? भन्दाखेरि
strongly correlated.
Strongly negatively, right? Negatively correlated. Strongest भनौँ त्योभन्दा बढी strong हुनै सक्दैन है. So मैले त्यो भनेको थिएँ नि त हैन last time. So let me show you that. है हेर्नुस् त मैले के भनेको थिएँ भन्दाखेरि जब तिनीहरु टम्म एउटै लाइनमा मिल्छ नि then it's the strongest. It's negative because the slope is negative and slope negative छ र ठ्याक्कै एउटै straight line मा छ यताउता गएको छ कुनै पनि point no all those 100 points जसै एउटा pointsहरु छ हैन all those 100 points are in the exact same line है straight एउटा straight line मा line up भएको छ है because the relationship is strongly negatively correlated right? Okay, यसैमा हामीले if I put this अब चाहिँ के हुन्छ अब मेरो correlation कति हुन्छ? What is my correlation now?
1
हुन्छ है so भनेपछि भनेपछि what do we expect? हाम्रो expectation हाम्रो के हुन्छ भन्दाखेरि of course यो चाहिँ कस्तो हुन्छ भन्दाखेरि it should be positive के हुनु पर्यो it should be positive slope हुनु पर्यो अनि lined up exactly lined up just like this. Okay? So you'll see that here. Exact. So if time will this is the strongest. Right? Okay. So you okay, you saw that, right? Okay, so this is about 0.8587 and 0.87. Okay. Anyway, so enough of this. I hope you guys understood. Any questions, Lisa? Do I have any questions so far on this one? So let's move on then. Okay, here modifying values with fancy indexing. So this is what we are going to do today. Okay? Pick up from last time. Okay, fancy indexing can be used to modify parts of an array. They just say कुनै पनि array को हामीले चाहिँ values हरु change गर्न सकिन्छ. Okay, so let's quickly do that. Okay. So let's see. Let's copy and paste here. So rather I have to okay. Okay, so now okay, so I have x equal to np.arrays 10. When you see, I have this x array, which is goes from 0 to 9. Okay, in step of 1. Right? This is I have I. So I'm going to run this one. Okay, I think units. Okay, so again let's read over x. Is this one? Now, what if I do this? Okay, so what if I do x? If I give I, which is an array, right, is equal to say 999. Right, so you got it, you'll see that okay wherever you have this, say 2 ma, yes, again it's a 999 answer. 1 ma 999, 8 ma 999, and 4 ma 999. Right, see, okay. So ekachoti you can see you have set all these values. See all these those positions, these indices that you provided. Yeah, but indices provide exactly thing indices now those values are set to this value, right? Okay, so does it make sense?
Yes, sir.
Very good. Okay. So very convenient, very convenient, right? Okay, so also you can do assignment operation, okay? So what if I do okay. What if I do now? Let's do that again. So this is my x, this is my I indices. So what if I do x I was equal to, right? Was equal to, let's say 1. What do you think is what's the result? What do you think is the result? Will be the result?
999 was 1000.
Very good, very good. Yes. Okay. So 999. So 1000 only one. Basically, you say 2, say yo, 2 when yo, index 2 when yo, school plus 1 add and this is my assignment. Right? So it's obvious. This is quite obvious. Right? Okay. All right. So likewise, I can do the same thing. Okay. All right. The next thing we're going to talk about is sorting arrays. Right? How can we sort arrays? Right? Right. NumPy has sorting functions, which are much faster than built-in sorting functions. So in order to return the sorted version of the array without modifying the input, we can use np.sort, right? NumPy could sort. This is much faster, much optimized, right? Rather than, so of course this built-in time, you don't have to use a library like NumPy sorting. Essentially errors like the default formula, right? But when you have bigger rates, then that makes a difference, right? It does make a difference, okay? So let's see. So say, let me just copy this. Vesma, please. All right, so this is my x. Okay, so here's my x, right? But I want to sort it. Very simple case of np.sort. You can do x, right? See, now I get this sorted, right? Minus 3 upon the sum of so this was 0, this was 3, this is 4 and 8, right? So np.sort, okay. Okay, so very simple. It doesn't change the original array. The original array is still intact. Right? The original array changed by data. Right? We got the same thing here. Right? Nothing. I mean, it hasn't modified. It's modified shortly. Right? Array. Right? It's giving us a new array. Right? Okay. Okay. All right. So so we can do sorting like that. Okay. So so if you want to in-place sorting, going to then you can call the method on it. Okay? You can call the method on there. Array method call. Okay. So when you say x dot sort. Right? So if you do this, see x is changed. X may in-place sorting by. Right? Whenever see x name modify x name now it's in sorted form, right? Okay, now the original x, right? Your x for example. So this is the original x. Right? Now same x, when you do x dot sort, then it's give in place sorting by. Now the x sorted form. right? Now, guys understand the distinction, difference between np.sort use garnu ra array mai sort call garnu. बुझ्नुभयो तपाईहरु?
Yes, sir.
Okay, great.
Originally change हुने भयो अर्कोमा चाहिँ.
This np.sort ले के गर्छ? Does it change the original array?
No, sir.
तर तपाईले if you call sort method on that array, same array मा तपाईको sort call गर्यो भने के हुन्छ भन्दाखेरि it changes the array
Permanent.
in place sorting. Very good. Okay, very good. All right, so another thing is something called arc sort, right? Arc sort. Okay, so let's see that. Okay, so let's talk about arc sort. Arc sort like it gives you the sorted index things. I sorted index. Okay, so arc sort like it gives you the index sorted index things rather, right? So let's try this again and the same. Okay, actually we changed it, right? So we need to, let's go back to that. Yeah. So x, so this is our unsorted x. This is unsorted. Okay, how about this is unsorted? So we need to use arc sort. Okay, arc sort user. So np dot arc sort. Okay, np dot arc sort and x with that. So what did it give you? It gives you, see, this indices theory. Okay, so let's quickly show you. Okay, so it's my keyboard lady. Okay, if you look at this, snippet so that we can see. Okay, so here we go. This one, see. So let's draw put the indices there. Indices here. Right? So this is index 0, index 1, index 2, index 3, index 4. Huh? You will see so सबभन्दा सानो index कुन छ यति भरिमा smallest index के छ भन्नुस् त indices है सबभन्दा सानो कुन छ
Index 2.
Index 2, very good. -3, which is index 2. Next say कुन छ
3.
3.
Index 3.
Index 3, which is 0. हैन यो भयो अब index 3, which is 0. Index दिन्छ के अहिले next त्यो भन्दा ठुलो 0 भन्दा ठुलो कुन छ it's 0.
Index 0. Nice.
Index 0. Likewise, the next one is
Index 1.
Index 1. Again, next one,
Index
of course, index 4. Okay, so that's what's giving us. Okay, right? So let's see your index things again rather. Right, 23014 means so arc sort when indices. Okay, so indices, so you can think of them as arguments, right? Arguments, so you can think of them, right? Okay, makes sense. Arc sort. Arc sort कुरा बुझ्नुभयो? Any questions? Okay. All right. So, all right. Of course, अब तपाईले यसको arc sort नै use गरेर, if you want to get the actual elements हरु नै पाउनको लागि के गर्नु? Arc sort नै use गरेर. So you can do किनकि यसले index दिन्छ अनि तपाईले फेरि fancy indexing गर्नु पर्यो हैन? So तपाईले के गर्नु पर्यो भन्दा x गरेर फेरि यहाँनेर np dot arc sort x गर्यो भने we should get the actual values. हैन? यहाँ चाहिँ के भयो fancy indexing भयो है यसले हामीलाई index दिन्छ अनि x मा हामी fancy indexing गरिरहेका छौं है makes sense है okay all right so we get the actual values right there okay let's see okay All right, sorting along rows or columns. Yeah, well, how about, can we sort, say, I mean, multi-dimensional arrays? Can we sort, for example, in two-dimensional array? Can we sort along the x, along along the rows or along the columns? Of course we can. Hey, so let's go back here. Okay. So I'm just copy again. Paste it here. Very good. Okay, so now if I do x, so this is my x, right? So so it's a 2 by 2. Yeah, right? Not 2 by 2. Sorry. 4 by 4 by. I mean, two dimensional, right? It's 4 by what? 1, 2, 3, 4, 5, 4 by 6.
6.
4 by 6. All right, 4 by 6 goes up. Now I want to sort. So what if I do this? np dot sort x. Okay, let's try it. Right. See, so whenever it's a keyboard, what did it do? Did it do anything? Yes. When it's keyboard, np dot sort x or right keyboard.
Row wise ascending order में value
Mhm.
assign करता है.
Yes, that's right. That's right. Right. Keyboard, row wise. Ascending. Very good. Okay, ascending order. Okay, row wise ascending order. So as you can see here, it's the order 6, 3, 7, 4, 4, 6, 9. यो चाहिँ हैन के केमा भयो सबभन्दा सानो यसमा के छ 3 छ यस नेक्स्ट 4 छ नेक्स्ट 6 अनि 6 दुईटा 6 भइहाल्यो अनि 7 अनि 9 है यहाँ हेर्नुस् न सो लाइकवाइज सबै रोहरु so so what if I want to do this sorting along the columns like column wise गर्नु पर्यो भने के गर्ने है so how if I do I want column wise any idea
Axis लाएर
yeah right
गर्न मिल्छ.
axis के दिनु पर्ला यसमा
1.
column wise गर्दा 1 हो र
0 sir. Column wise 0.
एक उल्टो हुन्छ हैन एक उल्टो हुन्छ हैन so let me do that here okay so what if I do yes np dot sort हैन so if I put x comma axis is equal to 0 हैन 0 को axis 0 दियो भने row wise के column wise हुन्छ ठीक उल्टो हुन्छ कि 1 दियो भने चाहिँ row wise हुन्छ है so let's see yeah did it work yes understand see column wise by you say 6 2 7 5 understand 2 5 6 7 sorted order right 3 6 2 1 ke 1 2 3 6 yes 1 2 3 6 this figure you saying 4 5 7 7 4 5 7 7 and so on okay yeah it did work right so this figure if I want to if I do put 1 then के भयो डिफल्टमा जुन अघि भएको थियो नि सो np dot sort x मात्रै गर्यो भने चाहिँ त्यो गर्नु र है so let me show you again this is my x right np dot sort x is equal to 1 गर्यो भने row wise हुन्छ कि column wise हुन्छ
row wise हुन्छ sir.
row wise हुन्छ है so यो गर्नु र हैन यो गर्नु चाहिँ एउटै हुन्छ है हेर्नुस् त aren't these results the same your result र your result they are exactly the same right so when we say by default मैले np dot sort गर्दा by default के हुन्छ x is equal to 1 हुने रहेछ है त्यो लाइब्रेरीमा उले त्यो लेख्दाखेरि अनि यो रुटिन लेख्दाखेरि उनीहरुले यसलाई by default x is equal to 1 पहिले राखिदिएको छ so we don't have to provide value right anyway you can do it explicitly like this as well right explicitly गर्दा पनि भयो है okay so far ठिक छ बुझिराख्नु भएको छ सबैले this
Yes,
is
sir.
okay, very good all right so पनि भयो all right so there's something called partial sort right partial sort or partitioning partial sort. Hey, partial sort, or also called partition. Okay, so partition, I did spelling fixing, partitioning. Okay, so now what we can do is, okay, we can use the same x from before. Okay, so how about this? So I have this x, right, which is unsorted, right? So if I do np dot partition, okay, अनि मैले x दिएँ अनि मैले say 2 दिएँ, okay? So let's see what happens. अब यसबाट के भयो भन्दाखेरि see अब is it sorted? Sorted भयो त? थाहा छैन है, because it's the -3 or in this case, yeah, it is looks like it's sorted, yeah. But how about this? Yes, 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 यसमा चाहिँ के भयो? Does it look like it's sorted? Sorted छ यो?
No, not
China, sir.
sorted.
Not sorted, right? You know, 0 अगाडि आएछ, -3 त्यसपछि आएछ, फेरि 3 आएछ. It's not sorted, but के भयो भन्दाखेरि यहाँ exactly के भइरहेछ भन्दाखेरि, let me show you, right? यसमा, let's take this one. So what's happening is this. So हामीले के गर्यौं भन्दाखेरि np dot partition x र 2 दियौं अथवा let's ignore this part now, right? This. So यसमा x3 गर्दाखेरि यसले चाहिँ के हुन्छ भने okay, यसको मतलब के भन्दाखेरि I'm just concerned with I need the least 3 numbers, that's it, right? Least 3, है मलाई यो सबभन्दा अगाडिको जुन यो 3 वटा छ है त्यो चाहिँ त्यो array सबै array भरिमा सबभन्दा least 3 हुनु पर्यो, है. They do not have to be in sorted order or anything, है. यता यो तपाईं यो बाँकी चाहिँ I don't care, है. I don't care, है. बाँकी चाहिँ I don't care, है. But all I do care about is I need the मेरो सुरुको 3 वटा चाहिँ I need them to be the least 3, है. Least 3 चाहिँ हुनु पर्यो out of all those arrays. जस्तै यसमा पो अब हाम्रो 4-5 वटा छ हैन, तर we could have millions of them, हैन. हाम्रो arrayमा चाहिँ millions, हैन, millions of elements हुन सक्छ, and millions of items हुन सक्छ. यसमा I want least 3, that's all I need, है. And then this with your least 3 आएपछि अब यो sorted order हुनुपर्छ भन्ने मलाई चाहिँदैन त्यो, है. अनि त्यसपछि जे हैन I don't care यतातिर के हुन्छ I don't care, है. यो कुरा बुझ्नु भयो? बुझिराख्नु
Yes,
भएको
sir.
छ? Yeah. So हेर्नुस् त, so okay, so यसले चाहिँ so why do we need to do that? हामीले अब सिधै sorting गर्दा पनि त हुन्थ्यो नि, sorting गरेर first 3 वटा लिएर भइहाल्थ्यो, हैन. It's going to give you the same thing, right? np dot sort, yeah. If I do x, so yeah, when we say yeah, it's going to give me the first 3 elements, which are of course the least 3, right? But why do you need, why do we need this? हामीले partition किन गर्ने? जब कि sortले नै त्यही काम गर्छ भने partition किन गर्ने त? के लाग्छ तपाईहरुलाई?
त्यसको इन्डेक्सिङहरु पनि आइडेन्टिफाई गर्नलाई सजिलो हुन्छ भनेर हो के?
indexing त यसमा त अब यसको indexing को कुरा छैन नि सर. यसमा त यसले indexing दिनु भएन नि त, हैन. indexing को भन्दा पनि is something else. अब यसमा के हुन्छ भने जस्तै तपाईको do anybody else want to try? Okay, anyway. So जस्तै यसमा जस्तै तपाईको यसमा million, है, million वटा तपाईको elements हरु छ भने तपाईलाई त्यो million मध्ये least 3 चाहिएको भने पुरा sorting गर्दाखेरि के हुन्छ? त्यहाँ तपाईको computational cost कति आउँछ? Very high, हैन. हरेक किन तपाईलाई चाहिँ चाहिँदैन भने किन त्यो खर्च गर्ने? Computational cost भनेको पैसा जस्तो हो नि त, हैन. So you're expending those computational costs for nothing. You don't need that, है. भनेपछि तपाईले partition गर्यो भने त्यसले ठ्याक्क 3 वटा ल्याएर दिन्छ अनि त्यसपछि छोड्दियो, हैन. computational cost बच्यो, तपाईको टाइम बच्यो, हैन. टाइम एकदम फास्ट पनि भयो र त्यसले चाहिँ computational cost चाहिँ तपाईँको CPU साइकल्सदेखि लिएर होइन मेमोरी होइन इन मेमोरी